So far in our pursuit of physics, we have been stuck on a line in one dimension. It's like all I can do is left and right. Maybe I can get like up and down, but that's it. Like now we're gonna study stuff. There's like break free 2D. Okay, get to that. Get excited. I see it. All right, so by the end of this lesson, you'll be able to sketch two-dimensional vectors on a coordinate plane. You'll be able to add and subtract two-dimensional vectors graphically, calculate the resultant of two-dimensional vectors that lie on an axis, and calculate the components of 2D vectors. Here we go. All right, quick review. Coordinate plane, positive x, positive y, negative y. 0 degrees, 90, 180, 270, 360. First, second, third, fourth quadrant. Okay. You also could be describe things as directional. So like the cardinal rose or whatever that's called. Northeast, southwest. Never eat soggy wheat, sour worms, whatever it is you're never supposed to eat, don't eat it. Okay. Good with that? Okay. So here are some things you might see how vectors are communicated in physics. Go 40 meters, or you're traveling 40 meters a second at 30 degrees below the x-axis. What does that look like? So that's the same thing as saying for 40 meters a second at 330 degrees, 30 degrees below the x-axis. Rarely am I going to make you use a protractor. You're just kind of estimating, sketching. So like, yep, that looks about like 30 degrees. And that's below the positive x-axis at 40 meters per second. Go to that. Okay. And then what would happen if I said it's a negative 40 meters a second at 330 degrees? What happens when you make a vector negative? Flips, goes in the opposite direction, 180 degrees in the opposite direction. Okay, so that's 30 degrees at 40 meters per second. So that would be that dude. Good with that? Okay. So another way you could see this is 150 meters at 70 degrees west of north. In order to decipher this, here's how you do it. You read this backwards. Okay. You have 150 meters at 70 degrees west of north. To do this, what we're going to do is start with north, and we're going to read backwards. So we're starting at north, and then we're going to go west. How far? 70 degrees. So that's 70 degrees. I just drew the arrow just to communicate what I'm doing there. And this vector is 150 meters. Does that make sense? Okay. So read that backwards. All right. So let's say we took a trip, and that trip was 500 meters south, and then we went 1,300 meters west. I want to know the resultant displacement of my trip. Okay. So to begin with, what we're going to do is we're going to draw both legs of that trip from the origin. So I've got 500 going south and 1,300 meters going west. Okay, start at the origin. And then next up, so a vector has a head and a tail. Has a head and a tail. I'm going to take one of those vectors and I'm going to cut and paste it and move it so the tail of one is at the head of another. Okay, so I'm clipping this. I can move this. I have freedom to move this anywhere and everywhere, except like so long as it's pointing in the same direction and the same magnitude. But I'm gonna put it down and paste it in a certain spot so that the tail is at the head of the green. Okay, and this is known as head to tail method. Okay, good with that. And then to find the resultant, what I'm going to do is I'm going to start at the origin and I'm going to draw to the final head. That would be my resultant displacement. Okay, the displacement is how far and in which direction you were from where you started. Okay, so that's a pictorial representation of that. How could I figure out a number, a measurement for that? Pythagorean theorem. Everybody seeing that? Okay, so to find the resultant, this is my hypotenuse. So I'm going 500 squared plus 1,300 squared equals c squared. And I find c to be equal to 1,393 meters. Good there? Okay. Now, for displacement, it's a vector. We're finding the resultant vector. A vector communicates two things. What are those two things? Magnitude and direction. Okay. We found the magnitude. It's 1,393 meters. But what about the direction? If I said southwest, that's not false, but it's not very accurate because southwest could also mean that, or this, or that. So I've got to make it more specific. Oh, maybe like finding this angle. Okay. Now, here's my recommendation. How would I find this angle? How would I calculate this angle using the 500 and the 1,300 and not the 1,393, because I might have messed up and also I probably rounded this. So how would I figure out that angle? I want you to think of the trig function. Using the 500 and the 1,300 and tell your neighbor. Correct. Trig function is tangent. Got opposite and the adjacent. So I'm going to say tangent theta is equal to 500 over 1,300 if you know you struggle with this, I would highly recommend reproducing this on your calculator. Find that to be 21 degrees. Make sure you know how to solve that. Okay? There? Okay. Now, if I told you, I want you to walk 1,393 meters at 21 degrees, most all of us, hopefully, would be like, okay. Like, oh, no, that's not what I meant. I mean, So do you see how we need to be a little more specific? Okay. So you could say, you've got some choices here. You could say the resultant is 1,393 meters at 21 degrees below negative x-axis. Could say that. You could say at 21 degrees south of east. Or you could get mathy and recognize that angle and say at 201 degrees, because you're adding 180 to 21. Good with that? All of those are legitimate, are true, be acceptable. Good with that? Okay. So when you walk 500 meters south and then 1,300 meters west, the resultant displacement, how far and in which direction you got away from where you started, would be 1,393 meters at 21 degrees south of east. Okay. Popular follow-up question is, well, Mr. Smiley, how did you know to copy and paste the purple one? What happens if you did it to the green one? Good question. It would be the same. The only difference, though, is that you're calculating this angle. Okay. Your tangent is going to be 13 over 500, sorry, 1,300 over 500, opposite over adjacent, and you're going to find your theta to be 69 degrees. So you could say 69 degrees to the left of the negative y-axis, or you could say at 69 degrees east of south. So all 5 of those are correct, valid, acceptable. Good with that? Okay, that's known as head to tail. Often I'll refer to that as cutting and pasting. Okay. So just like in adding, 2 plus 3 equals 5, 3 plus 2 also equals 5. The order of which you add doesn't matter. The order of which one you cut and paste does not matter. Find the resultant. Okay. Here's a popular error. Oops. You're here and I say, find the resultant. And you're like, okay. Boom, there it is. Okay. You will find the right magnitude, but good luck on the direction. Okay. Always remember to cut and paste first. Always remember you have to start at the origin to find your resultant. Draw at the origin, draw away to the final head. Okay. Good with that? Thumbs up when you have a guess. Tell your neighbor. So there we go. D. Dangerous dinosaurs. Okay. B. Cut and pasted correctly. They just drew it in the wrong way. Okay. You have to go away from the origin here. They didn't cut and paste. You always have to go start at the origin and draw to the final head. Good? This one, watch out. I am subtracting. Which one am I applying the negative to? T, the green. What happens when you make something negative, a vector negative? Flips it. Talk to your neighbor.
No, 270 is down. Yeah.
Okay. Let me walk you through it. What do you say? Okay, so I am applying the negative to the green vector. So that means it's going in the opposite direction. And then I'm going to cut and paste. And then start at the origin and draw away from that one. Okay? When you add, it does not matter. 3 plus 2 equals 5. 2 plus 3 equals 5. Did I say that? 3. Anyway. But when you subtract, does the order matter? Yes. Absolutely. Okay? Please deal with the negative first. Flip it. And then you can cut and paste. Good with that? Talk to your neighbor. Ready? Correct answer is? Correct answer is C. If I cut and pasted B, so I'm keeping the same direction and the same length. Copy and paste. The resultant, I start at the origin and I draw to the final head. Okay. I could, if I wanted to, copy and paste A, and then start at the origin and draw to the final head. Okay. Learn some stuff. How about subtracting? Tell your neighbor.
You're still right. Yes. The x-axis.
Okay, which one are you applying the negative to? B. So, consequence of that is now negative B is going this way. Okay. And then we cut and paste. So our resultant is A. Go with that. How we doing? All right. Have a conversation.
So in 4 scrolling down, so you like find your oh wait, and then you're also going down. But you're going down by 3. So 3 squared plus 4 squared is oh, that's fine. Yeah, so it's like both like on that side.
Okay. So you are swimming at 3 meters a second, perpendicular to the current. The current is going 4 meters a second, So your resultant velocity is what? Cut and paste. 3, 4, 5 triangle. 5 meters a second. Okay. Here's a demonstration to help us visualize that. Okay, get to a place where you can see this. Here is our swimmer. Okay, and this is how fast our swimmer swims in still water. Okay, that's how fast you can swim in a swimming pool. Okay, you good with that? If you can't see this, get up and move so you can, because otherwise it's kind of a worthless demonstration. This is going to be our river. Okay, now our river is going to be flowing this way. That makes sense? Okay, you're going to be swimming in the river. We're first going to go downstream, then upstream, and then across the stream. Okay, so we're swimming downstream. You can't see this, probably moves. Swimming downstream, it looks like this. Moving a lot faster. Okay, now if you're swimming upstream, you're fighting the current. Okay, and if the current's going faster than you can swim, get that? Now, this question, we're swimming across the stream. So it looks like this. You see that? Okay. So it did something like this. This. That makes sense? That's your resultant velocity. You're swimming this way, you're being carried this way, so the combination is this. Okay? Here's some practical application of this, besides swimming in a river. Video games. If you move forward and is it strafe? Is that the right terminology? At the same time, it's the resultant velocity of you moving forward and moving diagonal. You're going faster than you could do both. Here's a little life hack for you. Yep, physics. Times. Yep. All right. Next topic, components. Components of a vector tell us how much of a vector is going purely in the x direction and purely in the y direction. How much of a vector is going purely in the x direction, purely in the y direction? Components. All right. So let's say we take a journey going 120 meters at 30 degrees east of south. Okay. I want you to visualize how you would draw specifically at 30 degrees east of south. How would you draw at 30 degrees east of south? Thumbs up when you have a mental image of that. Okay, so we're going to read that backwards. And we're going to say start at south and go east. How far? 30 degrees. How'd you do? And we're going to label that 120 meters. Get that okay? Okay. Now, in your journeying, did you move in the southward direction at all? Was part of your motion towards like southward? Was all of your motion southward? But was some of it? Yes. How much of it was going purely in the south direction? Well, that's a good question. Oh, about that much. So I came up with that. Like, does that make sense? This is how much I went southward. This would be known as my y component. Because this is the displacement, I'm going to say delta y. It's my y component of the displacement. Okay. Think, employing trigonometry, what function, don't say this out loud, but what function would you use to figure out the green vector? Tell your neighbor. Correct answer is cosine. Okay, we're looking for our adjacent side, so we have cosine of 30 equals delta y over, adjacent over our hypotenuse. In your calculator, and you find that to be 104, like 103.9 meters. We're running out of juice. Yeah, getting better. Probably not. 104 meters. Okay. Now, is that going in the positive or negative y direction? It's going in positive or negative? Negative. How'd you know? Pointing down. It's going south. Okay. So we need to specify that. You could say either negative or south. Okay. Good with that? That's our y component. That's how much of our journey was purely in the y direction. Okay. We can have these same questions for the x direction. So was any of my journey going eastward? Was all of my movement eastward? Nope. But was some of it? Yep. How much of it? Well, about that much. See where that came from? Okay. Now, here's a little trick. See, this side is the same length as this side. Okay. You can do some geometry. Use your geometry prowess to figure this out. But my recommendation would be don't use the 104. You might have messed up and you rounded that. Okay, so how would you figure out delta x from 120 and 30 degrees? 120 meters and 30 degrees. Tell your neighbor. Correct answer is, what's trig function? Good job. Sine of 30. So sine opposite over hypotenuse. At what point in your educational experience have they taught you that sine 30 is 1/2? Is that a thing that you have already been ingrained in your brain yet? You get that in pre-cal?
Yeah, you get second semester.
All right. So here's a little foreshadowing. This is 0.5, and then so this is 60 meters. Okay. Is that going in the positive or negative direction? Tell your neighbor. There we go with positive. It's going to the right, going east. Okay. So these communicate how far you're going just in the south direction and just in the east direction. How much is going just in the y? How much is going just in the x? Okay. Now, have you heard the word components used prior to this class? Probably. Okay. Those are like the small pieces or parts. You can buy components, put together to make the whole, right? So check this out. We can take the blue and the green. These are X and Y components. If we find the resultant of these two, the blue and the green, we do head to tail, we get, what? That's like what we start. Whoa. Okay. So when we find the resultant of our components, we're left with our original vector that we had. That make sense? Okay. Okay. So that's components. All right. Answer this without a calculator just by process of elimination, assuming it's drawn to scale. Assuming this is drawn to scale, figure out what the answer is just based upon process of elimination. Talk to your neighbor. Tell them how you know it.
It's going more up than it is going to the left. So that's why. More than 3 foot high. Or the other one that could be but actually, which is
Correct answer is B. Okay. The X component is going in the negative direction, and it is shorter than the Y component. The Y component is longer. Good at that. Okay. So pull out a calculator and do this one. You might be able to figure it out by process of elimination, but soon you're going to be on your own without multiple choice. Figure it out on a calculator. Hopefully you found that to be a appropriate apples. Okay. Here's that. Okay, your only homework is to be dressed for outside on Monday, which by this time of the day shouldn't be bad. So we'll be doing a lab on Monday.
That depends. The weather being the way it is, it could snow on Monday. We don't know.
It's the Midwest.